Today we're going to talk about finding the square roots of perfect squares. So the first thing you are going to need to write down on a post-it, because that's where you write down your inside of your notebook, that is where you write down the definitions. We're going to talk about perfect squares. Now, a perfect square is a number with two identical factors. So for instance, the number 49. 49 can be represented as 7 times 7. Notice that 7 is identical to 7, right? They're the same thing. The other identical factor is -7 times -7, because a negative times a negative is a positive. Okay, so there actually you can represent 49 with two sets of identical factors, either both sevens or -7. Now note that -49 can't be represented with two identical factors. You could represent it as 7 times -7, but 7 and -7 aren't identical. They're opposites of each other. They have opposite signs. So negative numbers cannot be perfect squares, because one of the factors for a negative number would have to be negative while the other one would be positive. So they're not identical. Okay, so we are going to do a process called taking a square root today. And okay, a square root is one of the identical factors of a perfect square. Okay, if I say that I'm looking for a principal square root, what I want here is the positive square root. So like we saw in the last page, 49 had 7 times 7, and 49 had -7 times -7. Okay, so the square root, which I'm going to show you in just a second, this symbol in just a second, would be one of the identical factors, 7 here. And if I'm looking for the principal square root, I would only say the positive and not the negative here. Okay, so square root is one of the identical factors. The principal square root is the positive square root, and the radical is a symbol that indicates the principal square root. Okay, so for instance, if 81 is a perfect square, the square roots of 81 are both 9 and -9, because both of those numbers, is a comma here, both of those numbers are identical factors that when multiplied get you 81, but the principal square root, or radical 81, is equal to just 9, because this symbol indicates that you want the positive square root. But it's really important to remember there's actually two square roots. So let's talk about another one. Let's talk about 25. The square roots are 5 and -5, but the principal square root of 25 is just 5. Okay? Now here's a chart of the perfect squares from 1 to 30. Make sure to copy this down in your notebook. And I would say pretty solidly that you need to remember the perfect squares up to 16 squared, which is 256. Okay, this is really important to understand or to memorize in order to see the patterns that you have in numbers, especially when you get to Algebra 1 and you have to start to factor binomials, which you'll understand next year. But you should be able to recognize that 256 is a perfect square. Okay, I might even say to recognize them up to 25. It's really handy to have them remember, but definitely for my class you need to memorize the perfect squares up to 16 squared. So take a second and copy this down. Okay, so evaluating principal square roots, like we saw before, what we do when you see this symbol, we are just looking for the positive square root here. 256, if you look back here, 256 was 16 squared, so this would be 16 like this. Okay, square roots of negative numbers. Well, this type of thing, because -25 in the numbers that we are working with, -25, the factors would be 5 and -5 here. So there is no identical factor in the numbers that we are working with this year that would get you -25. So this right here in the real number system, this would not exist. Okay, so we're looking at real numbers, which are rationals and irrationals. However, just to give you a preview of next year, this is actually called an imaginary number, and we would actually write this as 5 with a little I here, a little cursive I. Okay, so we're not going to talk about that this year that much, but this is just a preview for what you're going to see next year. Okay, we're going to jump into another number system called the imaginary number system. And this number does exist in the imaginary number system. It just doesn't exist for us yet. It's sort of like when your teacher in elementary school said that you couldn't subtract, let's say that you were doing this and your teacher said, oh, you can't do that because you can't subtract 5 from 3. But now you know you can definitely do that because you know about integers, you know about negative numbers. Okay, so sort of it's the same thing that we're doing now. The operation can't be performed in the real number system. Okay, let's talk about perfect square fractions. A perfect square fraction is a fraction where both numerator and denominator is a perfect square. So 25 is a perfect square and 144 is a perfect square. So finding the square roots of them, what you're going to do is, or the principal square roots, is you're going to take the square root of this fraction. What you can do is actually just separate it into the numerator and the denominator. That's a property of a square root, that you can divide it up into numerator and denominator. Okay, and then take the principal square root of both of them, which is 5 over 12. All right, so no big deal. The principal square root of 25 over 144 is 5/12. That means that if I multiplied it by itself, I would get, 25 over 144. Okay. Lastly, equations using square roots. So let's say that I had to solve this equation. We have x squared is equal to 121. Well, you want to be careful here because what you're going to do is there's actually two numbers that when squared equals 121. All right. So you want to take the principal square root on both sides, except that if you did this, what happens is you just get 11. And that's really not representing all of the things that we could put in for here for x. So for instance, I could put in negative 11 because I know that negative 11 quantity squared is 121. So when I just come up with 11 as an answer, that's no good to me because I know that there's another answer there and I want to come up with as many answers as possible to this equation. So what you're going to do instead is use this little symbol called a plus minus symbol. Okay? So this x squared is equal to 121 can be solved by saying, well, x is going to be equal to plus or minus the principal square root of 121, which means it's going to be the positive principal square root and the negative principal square root. Well, the positive principal square root is just 11, and the negative principal square root is just negative 11. So x could be either 11 or x could be equal to negative 11. Okay, so let's say that you have an equation that had you had the x squared here plus 4. We know that x squared plus 4 is equal to 328. No problem. Let's subtract 4 from both sides. So we have x squared is equal to 324. And if we go back to our page with the perfect squares, let's see, 324 is 18 squared. So let's go ahead and say that the square root of x squared is going to be the square root plus or minus, remember that, 324, which is both 18 and negative 18. So if I put either 18 in here, 18 squared is 324 plus 4 is 328. Negative 18 quantity squared plus 4 is equal to 328. Okay? One quick word about using your calculator with this. If you take negative 18, okay, and on a calculator this symbol right here is for the sign of the number, this one is for the operation, and if I square that to check it, I say, oh, this should be, if I add 4 to this should be 328, right? And it gets to negative 320, like what happened here? Well, negative 18 squared is not going to be the same as when I do negative 18 times negative 18. That's because what your calculator, see, negative 18 squared is negative 324, whereas negative 18 times negative 18 is positive 324. That's because what your calculator is doing is it's squaring first, and then it's applying the negative. So it's doing essentially negative 1 times 18 squared. That's what it's doing to get negative 324. If you want the base of a fraction to be negative, then you must use parentheses. Okay, this is telling the calculator. Notice that this is your square key, right? This is a special exponent here. So you hit that and it puts an exponent of 2 on there. If you want the base to be negative, then you must use parentheses to indicate to the calculator that the entire thing is the base, not just the 18. And here you get what you want, okay? So negative 18 squared plus 4 is going to be 328. All right, a couple different ways to do a square on a calculator. You can either do 18 squared like this, or you can do 18, then use a little key called a caret key right here. And this puts me in the superscript here, and I can put 2. But be very careful, because if I did plus 4 right here, what's happening is that plus 4 is in the superscript. And really, you wanted that to be down in the regular part. So you have to go back and delete it, and then press your right arrow key, which gets you to the regular line. So here, to check my answer, I have 328. All right, and that's the end of the lesson for today. See you later.